So this question says that we have blood flowing through an artery and it's partially blocked. We want to know which part of the artery has the largest speed. Well, we know from the continuity equation that any blood that flows by that line has to flow through the second line as well. And we don't collect any of the blood any place. The fluid will flow in, it'll flow out. So the amount of blood, the volume of blood that flows through that area has to be in the same amount of time, or in 1 unit of time, 1 second. So the number of blood cells that flow past this point in 1 second has to be the same as the number of blood cells that flow through this point in 1 second, which is the same as the number of blood cells that flow through this point in 1 second. Well, a lot of them can get through here. We can do a parallel thing. We can have blood cells coming in over here, 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 here. Where over in this case, they really only have maybe 2 lines that they can go through, as compared to 4 in this case. So if we have 4, think of them as kind of go to a checkout in a supermarket, 4 checkout lines compared to 2 checkout lines. In order to have the same turnover rate, the same number of people being able to exit, these have to be moving out, through faster. These checkout people have to be scanning groceries very, very quickly. The blood cells that flow through this point have to flow through very quickly to let the other ones behind them through, so we have the same number that flow through in the same amount of time. So the narrowest part is actually what has the highest velocity.